Today we're going to move on to lesson 3, representing the data graphically. And this is going to be where we really start to read those dot plots and understand what they mean. So let's start with number 1. Number 1 says, a teacher drew a line segment that was 20 inches long on the blackboard. She asked each of her students to estimate the length of the segment and use their estimates to draw this dot plot. So A says how many students were in the class. When I'm reading a dot plot, I need to remember that each dot represents one person or one respondent in a survey. So if each of these dots is one student, to find out how many students are in the class, all I need to do is count the dots. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So there are 18 students in the class. B, were the students generally accurate in their estimates of the length of the line? Explain your reasoning. Okay, the word accurate roughly means correct. So this question is basically asking, when the kids guessed how long the line segment was, were they about right? I know that the line segment was 20 inches. So what I'm doing is I'm looking for the kids who were close. So I'm going to focus on this group right here because these kids were either right on 20 or they were 1 inch away. And I can tell that 10, 11, 12, 13 of the 18 kids were within 1 inch. That's pretty close. So I'm going to say here yes. 13 of the 18 students were within 1 inch, and 5 guessed the exact length, 20 inches. So that tells me that these students were pretty good with their estimations. Number 2, here are descriptions of data sets. Select all descriptions of data sets that could be graphed as a dot plot. So A says class size for the classes in an elementary school. If I'm going to graph that as a dot plot, let's just draw a little example over here. I might have classes that have 16 kids, 17 kids, 18 kids, 19 kids, 20 kids, and I could go all the way up. And then when I'm graphing it, I could use dots to represent how many classes have that size throughout the school. So A, could I use a dot plot to show class size? Yes, I could. So I'm going to circle A. Colors of cars in a parking lot. If I were to do a dot plot of different colors, maybe I would write red, white, blue, black. And then all I would have to do is I would have to count the cars that were each of those colors. So maybe there's 1 red, 3 white, 2 blue, 3 black. So could I use a dot plot for B? Yes, I could. C, favorite sport of each student in a 6th grade class. Instead of these colors, we'll just cross it out as a demonstration. Instead of red, could I have basketball? And then football, and then soccer, and count up that way using dots? Yes, I could. So C is also correct. I want you to consider D and E on your own. Could we use a dot plot? Think about it. Pause the video. All right, let's review. D says birth weights for babies born during October. So I'm going to draw that one down here. So could I say, well, we had babies that were 6 pounds babies that were 7 pounds, babies that were 8 pounds, 9 pounds, and so on. And then I could draw my dots to represent the number of babies that were each of those weights born in the month of October. Yes, I could. E, number of goals scored in each of the 20 games played by the school soccer team. We'll draw that one over here. So I could start with 0 goals, 1 goal, 2 goals, 3, 4, and so on. And then I could use dots to represent the number of games where they scored that many goals. So actually, every single one of these could be plotted using a dot plot like so. 3. Priya recorded the number of attempts it took each of her 12 classmates to successfully throw a ball into a basket. Make a dot plot of Priya's data. Okay, so for this one, I'm going to start it for you, and I'm hoping you can finish it. Down here, I have to put the number of shots that it took. So some students, it only took them 1 try. Some students, it only took them 2 tries. Look at the data and write down any other numbers that we need to include. Pause the video. Okay, so you should have also added 3, 4, and 5. We don't need to go above 5 because 5 is the highest number on my graph. Now I need to draw my dots. So I know that 1, 2, 3, 4 students took 1 shot. So I'm going to do 4 dots. How many students took 2 shots? 1, 2, 3. 3. All right, pause the video. Do 3, 4, and 5 on your own. Okay, let's check it. 3, I had 2 students take 3 shots. I had 1, 2 students take 4 shots. And I had 1 student take 5. Let's add these up and make sure we get 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That looks good. Okay, now what we're going to do is solve for the variable. This is actually review. So you'll remember you're trying to isolate or get the variable by itself. I'm going to do A and B, and then I want you to try C, D, and E. So let's take a look at A. 9V equals 1. What we have to do to solve this is the opposite of multiplication. The opposite of multiplication is division. So I'm going to divide this side by 9 to get the V by itself, which means I have to divide this side by 9. So what I end up with is that V equals 1/9. Okay, let's go to B. 1.37W equals 0. Once again, I have multiplication here. So I have to do the opposite of multiplication. I'm going to divide by 1.37. I'm going to divide 0 by 1.37. I know that 0 divided by any number is 0. So here, 0 equals W. Okay, pause the video. Try C, D, and E on your own. Okay, let's take a look at C. Once again, I see multiplication here, so I need to get my x by itself. So I have to divide both sides by 7/10. If I do it on the right, I have to do it on the left. Divided by 7/10. If I'm going to divide using a fraction, I have to do keep, change, flip. So I have 1 divided by 7/10. If I'm going to do keep, change, flip, here's what that's going to look like. 1, but I'm going to do over 1 just to make it easier on myself. So that's my keep, change to multiplication, flip, 10/7. So I multiply straight across. 10 times 1 is 10. 7 times 1 is 7. So I know that x equals 10 over 7, or 1 3/7. So that's my final answer for C, equals x. Okay, let's go up here, D. This time I have addition. The opposite of addition is subtraction. I know that I can add in any order. I can go 12.1 plus y, or I can go y plus 12.1. It doesn't matter. I'm going to subtract 12.1 from the right, which means I have to subtract 12.1 from the left. 12.1 minus 12.1 gives me 0. So D, I have 0 equals y. E, 3.5 plus z equals 1. Again, I can do this in any order. I can do z plus 3.5. So if I'm adding 3.5, I need to subtract 3.3, I'm sorry, not 3.5, 3/5 from the left, which means I have to subtract 3/5 from the right. Okay. I'm going to go over here. Hopefully no one gets confused. Just in case you do, I'm actually going to erase this previous answer so I can use this workspace. So I have 1 minus 3/5, and that's going to equal z. So when I'm adding and subtracting fractions, the denominator has to be the same. So instead of having 1 over 1, I'm going to convert this to fifths. So 1 becomes 5/5 minus 3/5. Sorry, that equals 2/5. So my final answer to E is 2/5. 5 is find the quotients. Quotient means that all I'm doing is a division problem. So for 5, I have a fraction. So we're going to do a little bit of keep, change, flip. All of these, I'm going to go ahead right now and put a 1 in their denominator, just to make it easier on myself. I'll do A, you do the rest. A, 2/5 divided by 2 over 1 equals 2/5 keep, change, flip 1 over 2 equals 2 times 1 is 2, 5 times 2 is 10. If I lower this to its simplest form, I can divide both by 2, and I end up with 1/5. Pause the video, try B, C, and D on your own. Okay, let's review B. 2/5 divided by 5 over 1. Keep 2/5. Change. Flip 1 over 5 equals 2 times 1 is 2. 5 times 5 is 25. I cannot simplify this, so my answer is 2/25. Okay, C, I'm going to actually scroll down here just to give myself some room. I'll show my work right down here below. Keep 2 over 1. Change. Flip 5 over 2. Gives me 10 over 2. 10 divided by 2 equals 5. 5 is my final answer for C.